Imagine for a moment that you are walking along an ancient and a deserted shoreline, and there, half buried in the sand, you find a sealed and a beautiful glass bottle. You can see that inside it holds a rolled-up piece of parchment, a message from a time and a place that is not your own. This simple and beautiful idea, the message in a bottle, is one of the most powerful metaphors for the work of an astronomer. For centuries, we have been studying the comets of our own solar system, and we have come to see them as exactly this. They are our own beautiful icy messages in a bottle, sent to us from across the vast ocean of our own history. These comets are pristine and frozen, and almost perfectly preserved fossils from the very birth of our solar system, some 4.6 billion years ago. And by carefully studying their chemical composition, we can read the message that they contain. It is a message that tells us about the original, primordial ingredients from which our own Earth and all the other planets were made. The story of the comets has, for a long time, been the story of our own origins. But in the year 2025, for only the third time in all of human history, a new and a different kind of bottle washed up on our cosmic shore. Its journey was far longer, its message far older, and its origin completely unknown. This new messenger was given the name 3I Atlas, and it is not a message from our own past. It is a message from a lost world. It is a direct, a physical, and a beautiful sample of the raw materials from another, an alien solar system, and the quiet and the patient work of reading the secrets that are written in its ancient ice and dust has now begun. The story that this distant and mysterious traveler has to tell is not about us. It is the first, clear physical sample that reinforces the vast and wonderful diversity of the other, unseen solar systems that fill our galaxy. Before we begin to carefully and gently unseal this ancient cosmic message and to read the secrets that it contains, I would love to know from which part of our own quiet corner of the galaxy you are listening tonight. Please write your city or your country in the comments below. It is a beautiful way to feel our shared sense of place as we prepare to look upon a sample from a world that is not our own. And if you enjoy these calm and educational journeys to the frontiers of our knowledge, please consider subscribing to the channel. Your support is the quiet and the patient energy that makes these explorations possible. The study of an object like 3I Atlas is the birth of a new and a beautiful kind of science. It is a kind of astro-archaeology. Think of it in this way. A terrestrial archaeologist can take a single, small fragment of ancient pottery, and from it can tell a rich and a detailed story. By analyzing the type of clay, they can know the geology of the region where it was made. By studying the way it was fired, they can know the level of technology of the culture that created it. And by looking at its shape and its decoration, they can learn about the art and the rituals and the daily life of a people who have long since vanished. An astronomer, a quiet and a patient astro-archaeologist, does exactly the same thing with a distant and an ancient comet. The comet is our artifact, and the tools we use to study it are our telescopes. By using the science of spectroscopy, we can analyze the faint and the beautiful and the ancient light that the comet reflects and emits. And in this light, we can see the chemical fingerprints of the different ices and dust grains that it is made of. This is the equivalent of analyzing the comet's clay. It tells us about the primordial chemical recipe of the star system where it was born. By using the science of photometry, we can measure the comet's brightness, its color, and the way that its light is polarized. This is the equivalent of studying the artifact's texture and its glaze. It tells us about the size and the shape and the structure of its dust grains, and about the physical conditions of the environment in which it was formed. And finally, by using the science of orbital dynamics, we can trace the comet's long and beautiful path through our solar system, and we can work backwards to understand the incredible journey that it has taken to reach us. This is the equivalent of knowing the precise archaeological location where the artifact was found. The story that we are about to explore, then, is the story of this great and quiet and cosmic excavation. We will, together, become astro-archaeologists. We will take our one precious and beautiful artifact, the Comet 3I Atlas, and we will ask it the great and the quiet questions. What does its strange and its beautiful and its carbon dioxide-rich chemistry teach us about the different ways that solar systems can be born? What does its incredible and its record-breaking speed tell us about the violent and the chaotic youth of other distant star systems? And what does its very existence, its incredible and its patient survival after a journey of perhaps billions of years, teach us about the vast and the silent and the beautifully interconnected nature of our own galaxy? Before any lessons can be drawn from the arrival of our interstellar visitor, a clear and a careful portrait of the messenger itself must first be painted. The story of what 3I Atlas can teach us about other solar systems is built upon the foundation of what our own science has managed to learn about this specific and extraordinary object. In the months following its discovery in July of the year 2025, a quiet and an intense global campaign of observation, a focused and a collaborative effort involving our most powerful telescopes, has revealed a visitor that is superlative in almost every measurable way. This is a summary of that knowledge. It is the known and established dossier of facts from which all of our subsequent explorations must begin. The first and most fundamental of all its characteristics is its origin. The comet's path through our solar system, as tracked with an incredible precision by observatories all over the world, is a deep and an extreme hyperbola. Its orbital eccentricity, a number which describes the shape of its path, is a staggering 6.1, a value that is dramatically higher than that of our previous two interstellar visitors, and which confirms beyond any doubt that it is not, and has never been, gravitationally bound to our own sun. It is a true and an unbound traveler just passing through. This trajectory is the result of its incredible speed, its hyperbolic excess velocity, v infinity. Its deep space cruising speed far from any star is approximately 58 kilometers per second. To place this velocity in context, it is nearly twice the speed of our second interstellar visitor, 2I Borisov, and it is more than 3 times faster than our own fastest ever outbound spacecraft, the Voyager 1 probe. This immense speed is the key clue that points to the comet's ancient and exotic origin. It is too fast to be easily explained by a gentle gravitational ejection from a nearby sun-like star. Instead, the science of kinematics tells us that this speed is the signature of an object that was born in the Milky Way's thick disk, an older, lower metallicity stellar population distinct from the halo, whose stars are, on average, billions of years older than our sun. A key lesson from 3I Atlas, therefore, is its likely immense age. This is not just a visitor from another place. It is likely a visitor from a much more ancient time, a physical relic from an era of the galaxy's history that predates the very existence of our Earth. The second key characteristic is its strange and anomalous chemical composition. While the Hubble Space Telescope confirmed that 3I Atlas is an active comet with a glowing coma and a developing tail, it was the James Webb Space Telescope that revealed its most profound secret. The gas being released from its nucleus is not the familiar water-dominated mixture of our own local comets. Instead, the chemical fingerprint of 3I Atlas is overwhelmingly dominated by carbon dioxide. The ratio of carbon dioxide to water in its coma is on the order of 8 to 1, among the highest ever recorded in any comet. And this unusual chemical recipe that explains one of its other great mysteries, its surprising brightness at such a great distance from the sun. Carbon dioxide ice sublimates, turning from a solid to a gas at a much lower temperature than water ice. And so, the comet's carbon dioxide-rich nature allowed it to awaken and to begin producing a large, bright coma much farther out in the solar system than a normal, water-rich comet ever could. This chemical signature is a fossil. It is a direct and a pristine record of the specific physical conditions of the long-dead protoplanetary disk in which it was born. Finally, there is the physical portrait of the object itself. It is a difficult and a delicate art to measure the size of a tiny, solid nucleus that is hidden within a vast and a glowing coma. But the sharp and the powerful eye of the Hubble telescope has been able to place a strict upper limit on its size. The nucleus of 3I Atlas is no larger than 5.6 kilometers, or about 3.5 miles in diameter. Even at this maximum possible size, this makes it a relatively small object, but it also makes it, by a significant margin, the largest of the 3 interstellar visitors that we have ever seen, far larger than the tiny asteroidal Oumuamua and the sub-kilometer nucleus of 2I Borisov. The data from our ground-based sentinels has added the final brushstrokes to this portrait. The dust in its coma is distinctly reddish in color, the telltale signature of complex, carbon-rich organic molecules that have been weathered and processed by the harsh radiation of deep space over a journey of billions of years. And so, we have our messenger. It is an ancient and a fast-moving and a carbon dioxide-rich and an organic dusted and a mountain-sized snowball, a visitor of star system that likely predates our own by several billion years. These are the established facts. This is the evidence. And now, with this quiet and detailed portrait in our minds, we can begin the true and the patient work of our astro-archaeological investigation. We can begin to take these clues and to ask the great and the quiet question: what does this ancient and beautiful artifact teach us about the lost and the alien solar system from which it came? To understand what our interstellar visitor can teach us, we return to that astro-archaeology perspective. Spectroscopy reveals composition, photometry probes dust properties, and orbital dynamics traces its journey. It is the study of a physical artifact, a pristine and a precious relic that has been delivered to our cosmic doorstep from a long-vanished and a completely unknown culture. The culture, in this case, being the physical and the chemical environment of another star system. And just as an archaeologist can take a single, small fragment of ancient pottery and can use it to reconstruct the world of the people who made it, so too can an astronomer take the faint and the ancient light from a distant comet and can use it to reconstruct a picture of the world where it was born. Let us explore this beautiful analogy. An archaeologist's first question about a piece of pottery is a simple one: what is it made of? By analyzing the specific type of clay and the trace minerals that it contains, they can learn a great deal about the local geology of the place where it was made. An astronomer does exactly the same thing with a comet. The first and the most powerful tool in our astro-archaeological toolkit is spectroscopy. As we have learned, this is the art of breaking the faint light from the comet's coma down into its constituent colors, its chemical barcode. The specific signatures of the different ices that are sublimating from the nucleus, the water, the carbon dioxide, the carbon monoxide, are the equivalent of the comet's clay. They tell us, with an incredible precision, about the primordial chemical recipe of the protoplanetary disk in which this comet was first formed, billions of years ago. An archaeologist would then look at how the pottery was made. Was it fired at a high or a low temperature? Was its surface smooth or rough? This tells them about the level of technology and the specific techniques of the culture that created it. An astronomer has a similar tool, a science known as photometry. By carefully measuring the comet's brightness, its color, and the way that its light is polarized, we can learn about the physical properties of the dust grains that are being released from its nucleus. The reddish color of 3I Atlas, for example, tells us a story of complex, carbon-rich, organic molecules. And the way that this dust scatters the sunlight can tell us if the grains are small and fluffy or large and compact. This is the equivalent of studying the artifact's texture and its glaze. It is a message that tells us about the physical conditions of the environment in which the comet was formed. Was it a calm and a gentle place, where small and fluffy snowflakes of dust could slowly and gently accumulate? Or was it a more violent and a more turbulent environment, where the grains were more processed and compact? Finally, an archaeologist would consider the context of their artifact. Where precisely was it found? Was it in a tomb, a home, a temple? This context is crucial to understanding its purpose and its meaning. For an astronomer, the equivalent of this is the science of orbital dynamics. By tracing the comet's precise and beautiful path through our solar system, and by working backwards to understand the immense interstellar journey that it has taken to reach us, we can learn about the dynamic and the gravitational environment of its home. Its incredible speed, as we have learned, tells us a story of a violent and a powerful ejection, a clue that its home solar system was likely a chaotic and an active place, perhaps with giant planets in unstable orbits. Its ancient origin in the galactic thick disk tells us a story about the era in which it was born. A story that we are about to explore, then, is the story of this quiet, and this patient, and this beautiful cosmic excavation. We will, together, become astro-archaeologists. We will take our one precious and beautiful artifact, the Comet 3I Atlas, and using these tools of spectroscopy, of photometry, and of orbital dynamics, we will begin to gently and patiently read the ancient secrets that it has carried for so long and from so far away. This is not just the study of a single and a beautiful and a transient object. It is our first and best opportunity to study, at a distance, a physical piece of another world, and to read the story written in its heart. The first and the most powerful lesson that our interstellar messenger has to teach us is a story that is written in the very substance of its being. It is a lesson in the beautiful and the surprising diversity of cosmic recipes. We have for a long time held a simple and a comforting assumption that the way our own solar system was built is the normal way. We have imagined that the other, unseen solar systems of our galaxy are likely just variations on a familiar theme. But 3I Atlas, with its strange and its ancient and its profoundly different chemical makeup, has arrived as a quiet and a beautiful messenger to tell us that this is not the case. The galaxy is a far more diverse and a far more creative and a far more interesting place than we have ever known. To understand this lesson, we must first recall the chemical signature of the comets of our own solar system. They are, as we have learned, fundamentally water-based objects. The vast and overwhelming majority of the ice that is frozen within their nuclei is simple and familiar water ice. This tells us a beautiful and a simple story about the place where they were born, in the great and the swirling. And the primordial disk of gas and dust from which our own solar system was formed, there was an invisible and a crucial and a temperature-based boundary, a location known as the water snow line. Inside this line, closer to the young and the hot sun, it was too warm for water to freeze into a solid. Outside this line, in the colder outer reaches of the disk, water could condense into tiny and beautiful and pristine flakes of ice. Our comets were all born in this cold and wet and beautiful region far out beyond the snow line. But as we have learned from the beautiful and the revolutionary eyes of the James Webb Space Telescope, 3I Atlas is not a water comet. It is a carbon dioxide comet. The dominant frozen volatile in its heart is not water, but the substance that we know as dry ice. And this simple, and this beautiful, and this profound chemical fact tells us an entirely new and an entirely different story about its own long-vanished birthplace. Just as there is a water snow line in a young solar system, there is also, much farther out, in the even colder and even more distant regions of the disk, a carbon dioxide snow line. This is the place where it is at last cold enough for this less volatile gas to freeze into a solid. The chemical signature of 3I Atlas, therefore, is a direct and a beautiful and a fossilized piece of evidence that it was born in a region of its own ancient protoplanetary disk that was far, far colder and far, far more distant from its parent star than the birthplace of our own comets. And this single, quiet chemical fact opens up a universe of beautiful and of profound possibilities for what its home solar system may have been like. Perhaps it was a much larger system than our own, with a vast and an extended disk of material that stretched far out into the cold and the dark. Or perhaps its parent star was a different kind of star, a star that was much cooler and much dimmer and much redder than our own sun, which would have allowed these colder, carbon dioxide-rich regions to exist much closer in. Or perhaps, and most excitingly, its home was a star system that was born in a much more ancient and a much more chemically primitive era of our galaxy's history. 7 billion years ago, the great clouds of gas from which stars were born had not yet been so richly seeded with the heavy elements that were forged in the hearts of previous stellar generations. The specific chemical recipe of the building blocks of that ancient solar system was fundamentally different from our own. This is the great and the beautiful lesson that our messenger has carried for 7 billion years across the cold and the dark and the silent void. It is a lesson in the beautiful and the profound diversity of cosmic creation. The recipe for building worlds is not a universal one. Each star system is its own, unique and beautiful. Chemical experiment, and the quiet and the patient and the beautiful work of astroarchaeology, the work of studying these rare and these precious and these ancient interstellar visitors, is the only way that we have to begin to read the great and the diverse and the beautiful cosmic cookbook of our own magnificent and mysterious Milky Way galaxy. The strange and the beautiful and the carbon dioxide-rich chemistry of our interstellar visitor has now given us our first great lesson. It has taught us that the recipe for building worlds is not a universal one, that the galaxy is a place of immense and of beautiful chemical diversity. But this lesson, as profound as it is, immediately begs a deeper question. Why is its recipe so different? What was it about the home of 3I Atlas that made it so unlike our own? To answer this, we must now weave together the two great and primary clues of our investigation: the clue of the comet's strange chemistry and the clue of its ancient and its high-speed origin. These two clues are not separate and unrelated facts. They are, in fact, two sides of the very same beautiful and ancient coin. The ancient origin of our visitor is the very key that unlocks the secret of its strange and its beautiful chemistry. To understand this connection, we must now take our journey of the imagination back once more into deep time. But we are not just traveling to another place in the galaxy. We are traveling to another era of the galaxy. Let us travel back more than 7 billion years to the time when the star that would one day give birth to our comet was itself just beginning to form. The Milky Way galaxy of this ancient past was a profoundly different place than the one we inhabit today. It was younger, it was more turbulent, and its chemical composition was much more primitive. This chemical difference is the very heart of our story. In the language of astronomy, this is a concept known as metallicity. To an astronomer, a metal is any element on the periodic table that is heavier than hydrogen and helium, carbon, oxygen, silicon, iron. All of these are considered metals. And these heavy elements are the essential and the absolutely necessary raw materials for building rocky planets like our own Earth, and for the complex chemistry of life as we know it. But these heavy elements were not created in the Big Bang. The universe in its infancy was made of almost nothing but pure hydrogen and helium. All the other heavier elements, all the stardust that makes up our world and our own bodies, had to be created, slowly and patiently over billions of years, in the great nuclear furnaces at the hearts of stars. When a massive star reaches the end of its life, it dies in a colossal supernova explosion. In this final, beautiful, and violent act, it scatters all the new and the heavy and the life-giving elements that it has forged in its core out into the great interstellar clouds of gas and of dust. The next generation of stars is then born from these newly enriched clouds, and so, with each successive generation of stars, the galaxy as a whole becomes more and more enriched with these heavy elements. Its metallicity slowly and steadily increases over time. And now we can understand the world of our visitor. 7 billion years ago, the galaxy was a much more chemically primitive place. The great swirling cloud of gas and of dust from which the parent star of 3I Atlas was born, was in a very real sense a purer and a simpler one than the cloud that would billions of years later give birth to our own sun. It had a much lower concentration of heavy elements, and this different, primordial recipe for its protoplanetary disk would have had a profound and a direct effect on the kinds of comets and planets that could form within it. The strange carbon dioxide-rich nature of 3I Atlas is therefore not just a strange anomaly. It is, in fact, a beautiful and a predictable fingerprint of its ancient and its chemically primitive origin. In a star system with a different and a lower abundance of heavy elements, the specific locations of the different snow lines and the relative abundance of different kinds of ices would have been completely different. The comet's strange chemistry is a direct, a physical, and a beautiful fossil, a quiet and an undeniable message that is telling us a story about what the raw, planet-building materials of our galaxy were like, in a long-vanished and a much more ancient time. We are, in a very real sense, holding a piece of the young universe in our hands. This is the great and the beautiful power of astroarchaeology. The comet is more than just a visitor. It is a core sample, drilled from the deep geological strata of cosmic time itself. By studying this one, small and ancient object, we are learning, directly and physically, about the grand and the sweeping, and the multi-billion-year story of our galaxy's own, slow and patient chemical evolution. The chemical fingerprint of our interstellar visitor has now told us a beautiful and a profound story. It is a story of a different and a more ancient kind of cosmic recipe. Its strange and its carbon dioxide rich and its chemically primitive nature is a direct and a physical and a beautiful fossil, a quiet testament to the fact that the process of building worlds in our galaxy has changed over the vast and the silent eons of cosmic time. But the story that is written in the substance of this ancient messenger contains another and an even more profound and a more exciting chapter. for woven into its ancient reddish dust and frozen within its primordial ices are not just the building blocks of planets, but the potential building blocks of life itself. As we have learned, the reddish color of the dust in the comet's coma is the telltale signature of complex and of carbon-rich organic molecules. And the study of comets in our own solar system has confirmed that these icy bodies are rich and fertile reservoirs of these prebiotic chemicals. They are, in a very real sense, the great cosmic delivery trucks of the raw materials for biology. And so, the arrival of 3I Atlas, this ancient and pristine sample from a 7-billion-year-old star system, gives us our very first and our most direct opportunity to ask one of the deepest questions in all of science. Were the building blocks of life also common in the ancient and the chemically different era of the galaxy from which our visitor has traveled? The quiet and patient hint, whispered by the faint reddish glow of the comet's coma, is a cautious and beautiful "it may well be so." The presence of these organic molecules in an object of such incredible and of such profound antiquity is a powerful and a direct piece of evidence that the universe has been making the fundamental ingredients of life for a very, very long time. It tells us that the process of creating complex, carbon-based chemistry is not a recent, or a difficult, or a rare phenomenon. It seems to be a robust and a universal and an almost inevitable outcome of the physics and the chemistry of the cosmos. And this, in turn, allows us to dream a new and a more ancient dream about the story of life in our galaxy. In our old story, the one in which the heavy elements needed for life were only created slowly over many billions of years, our own Earth seemed to be one of the very first and most promising candidates for a habitable world. But the lesson of 3I Atlas is that the recipe for a life-bearing world may have been ready much, much earlier than we thought. The existence of these complex organic molecules in a star system that is billions of years older than our own opens up a vast and a new and a previously unimagined expanse of cosmic time in which life could have arisen elsewhere. It suggests that the great cosmic experiment of biology may have begun its work in other and in much more ancient solar systems, long before our own planet had even cooled from a molten ball. The journey of our messenger is also a beautiful and a physical proof of concept for the idea that is known as panspermia. This is not the idea that life itself is traveling between the stars. It is the quieter and the more gentle and the more plausible idea that the potential for life is being constantly and patiently shared across the galaxy. The 7-billion-year journey of 3I Atlas is a direct and a beautiful demonstration that these precious and these life-giving and these organic molecules can, in fact, survive a long and an arduous journey through the cold and the dark and the hostile environment of interstellar space. The comet's icy heart is the perfect and the most protective of all possible cosmic vessels, and its very existence proves that the great star systems of our galaxy are not isolated chemical islands. They are part of a single, vast, and interconnected ecosystem, constantly and patiently shuffling and sharing the precious and the life-giving seeds of their own unique chemistries with one another. We must, of course, hold this beautiful and hopeful idea with a necessary and a scientific caution. While the building blocks of life may have been present in these ancient and these thick-disk star systems, the environments themselves were likely much more violent and much more chaotic than our own modern galactic neighborhood. The stars were more active, the planets were less settled in their orbits, and the rate of catastrophic giant impacts was likely much, much higher. So while the ancient recipe for life may have been ready, the cosmic kitchen may have been far too turbulent and far too dangerous for that recipe to ever be cooked into a stable and a lasting and a living form. But the message of the messenger in this regard remains a profoundly and a deeply hopeful one. It tells us that the universe has been patiently and persistently trying to create the conditions for life, not just for the last 4 billion years, but perhaps for the last 10 or even 12 billion years. The story of life may be a far, far older and a far grander and a far more universal story than we have ever dared to imagine. The story of our interstellar visitor, so far, has been one of quiet and of beautiful revelation. Its ancient age and its strange alien chemistry have given us a profound and a humbling new perspective on the immense and the diverse and the creative nature of our galaxy. The comet's very substance, its primordial ice and dust, has been the messenger, carrying a quiet and a beautiful story of a different and a more ancient way of building worlds. But the story of a comet is written not just in what it is, but in how it came to be. And the second great lesson that 3I/Atlas has to teach us is a story that is told not in its chemistry, but in its motion. To read this next chapter, we must now turn our attention back to the great and the record-breaking and the almost impossible speed of its 7 billion-year-long journey. As we have learned, the incredible 58 kilometer per second velocity of our visitor is the key clue that points to its origin in the ancient and the chaotic and the high-speed environment of the galactic thick disk. But it also tells us another and an equally profound story. It tells us a story about the nature of its own long-vanished home. For a comet does not acquire such a speed on its own. It must be given a powerful and a violent and a gravitational push. The incredible speed of 3I Atlas is the unmistakable signature of a truly colossal and a truly chaotic ejection event. It is a quiet and a beautiful and a final, departing scream from a solar system that was in all likelihood a very, very violent place. In the relatively calm and the stable and the well-ordered architecture of our own solar system, the ejection of a comet is a rare and a relatively gentle event. But to fling a mountain-sized ball of ice and rock out into the cosmos with a speed of 58 kilometers per second requires a much more powerful and a much more dramatic gravitational slingshot. And this tells us a great deal about the likely character of the alien solar system where our visitor was born. It was almost certainly a place of great and of chaotic gravitational dynamics. Perhaps its parent star was not a single and a solitary star like our own sun, but was part of a binary or a multiple star system, a family of 2 or more suns, all locked in a complex and an ever-shifting gravitational dance. The planetary and the cometary orbits in such a system would be inherently unstable, and the ejection of small icy bodies would be a common and a frequent event. Or perhaps its home system contained a family of colossal and of gas giant planets in tight or in eccentric or in unstable orbits. These great gravitational bullies would have been constantly and violently stirring the pot of their outer solar system, flinging their own smaller, icy siblings out into the interstellar void with a furious and an almost unimaginable power. The great and beautiful lesson that is written in the speed of our messenger, then, is this: the quiet and the stable and the peaceful architecture of our own solar system is not the only way. It may, in fact, be a relatively rare and a fortunate exception. The story of many, and perhaps even most other solar systems in our galaxy may be a much more violent and a much more chaotic and a much more destructive one. The existence of 3I Atlas is a quiet and a beautiful testament to the fact that the process of building a solar system is not always a gentle and an orderly one. It can be a story of great and of violent and of chaotic gravitational battles, a story whose beautiful and whose silent debris is now and forever scattered across the great and the silent and the empty battlefields of interstellar space. And our visitor is a single and a beautiful, and a 7 billion-year-old veteran of one of these ancient and long-forgotten cosmic wars. The story of our visitor's motion has now told us a tale of a violent and a chaotic birthright. The incredible speed of 3I Atlas is a quiet and a beautiful testament to the fact that its own ancient solar system was likely a place of great and of powerful and of unstable gravitational dynamics. This act of ejection, this great and final push that sent our comet on its 7 billion-year-long journey, was for its home system a final and a definitive act of severance. But for the galaxy as a whole, it was something else entirely. It was the contribution. It was the moment that a single, small, and pristine sample of that ancient world substance was donated to the great and the silent and the ever-churning galactic canons. And in this single beautiful act of cosmic exile, we find our next great lesson. It is a lesson that transforms our view of the galaxy from a collection of isolated islands into a single, vast, and interconnected ecosystem. For a long time, we have thought of star systems, including our own, as beautiful but fundamentally isolated places. We have imagined them as cosmic islands, each one separated from the others by a vast and a dark and an almost uncrossable ocean of empty space. But the very existence of interstellar objects like 3I Atlas and its predecessors, Oumuamua and Borisov, has proven to us that this picture is wrong. The great, dark ocean between the stars is not an uncrossable void. It is a place of constant and of quiet and of patient travel. The islands are not isolated. They are, in fact, constantly, though very, very slowly, exchanging material with one another. The journey of 3I Atlas is not a singular and a miraculous event. It is, in fact, a quiet and a beautiful example of a process that is happening, constantly and silently, all across our galaxy. Scientists now believe that for every single star that shines in our Milky Way, there may be hundreds of thousands, or even millions, of these small and dark and unseen rogue comets and asteroids adrift and silently wandering in the great interstellar darkness. The galaxy, it seems, is not mostly empty. It is in fact teeming with this unseen and this ancient and this well-traveled debris. The 3 visitors that we have so far detected are just the very, very tiny and the very lucky tip of a colossal and an almost unimaginable and an invisible cosmic iceberg. And this vast and this unseen population of interstellar wanderers is performing a slow and a patient and a profoundly important task. They are the great cosmic pollinators of the galaxy. This is the beautiful process of galactic seeding. When a comet like 3I Atlas is ejected from its home, it carries with it a pristine and a frozen and a perfect sample of its home system's unique chemical recipe. It carries its water, its carbon, and its rich and its complex organic molecules, the very building blocks of life, out into the great interstellar medium. And over the course of its long and its patient journey, it can travel through and it can mix with the vast and the cold and the dark clouds of interstellar gas and of dust that are the great fertile nurseries of the cosmos. And these great dark clouds are the very same clouds that will, one day, hundreds of millions of years in the future, be pulled together by their own gentle gravity to collapse and to form the next new generation of stars and of planets. And this leads to a beautiful and a profound and a deeply moving conclusion. It means that the atoms and the molecules from one ancient and long-dead solar system can, and almost certainly do, become the direct, physical product and raw building blocks of another, a completely unrelated solar system that is born billions of years later and thousands of light years away. This story is our own story. The great swirling cloud of gas and of dust from which our own sun and our own earth were born 4.5 billion years ago was not made of pure and of pristine and of Big Bang era hydrogen and helium. It was a rich and a complex and a recycled soup. It was enriched with the stardust, the heavy elements that were forged in the hearts of previous generations of stars. But this new understanding adds another and a beautiful, and an even more intimate layer to our own story. Our primordial cloud was likely also seeded with the direct, physical, and cometary debris from countless other and ancient solar systems. The very water that fills our oceans today, the very carbon that forms the backbone of our own bodies, may not just have come from our own native comets. Some of it may have made an even longer and an even more ancient journey, born in the disk of another long-dead star, ejected into the great and silent void, and then billions of years later, incorporated into the beautiful and the fertile and the living soil of our own precious world. The galaxy is not a collection of separate and of lonely islands. It is a single, great, and interconnected family. And our interstellar visitor is not a stranger. It is a long-lost cousin, a beautiful and a tangible reminder of our own deep and ancient and shared galactic heritage. The story of our interstellar visitor has now revealed to us a beautiful and a profound new truth about our galaxy. The existence of 3I Atlas and the countless unseen wanderers like it has transformed our view of the cosmos from a collection of lonely, isolated islands into a single, vast, and interconnected ecosystem, a great cosmic garden where the seeds of new worlds are constantly and patiently being shared across the void. But this beautiful image of a connected galaxy must be held in balance with a deep and a sober appreciation for the journey itself. The great dark ocean of interstellar space is not a gentle or a benign place. It is an environment of incredible and of profound hostility. And so the next great lesson that our messenger has to teach us is a story of almost unimaginable endurance. It is the story of how a small and a fragile and an icy object can survive a 7 billion year-long pilgrimage through the most empty and the most desolate wilderness in all of the known universe. Let us now, in our quiet journey, try to imagine the long and the lonely voyage of our comet. After it was first flung out from its ancient and its long-vanished home, it began its drift through the interstellar medium. And this medium, while it is the closest thing in nature to a perfect vacuum, is not truly empty. It is a place that is filled with a constant and an invisible and a deeply penetrating rain of high-energy cosmic rays. These are the stripped-down nuclei of atoms, particles that have been accelerated to nearly the speed of light by the colossal, explosive deaths of massive stars, by supernovae, and by other violent cosmic events. And for 7 billion years, the surface of our quiet and our sleeping comet has been relentlessly bombarded by this silent and this energetic and this invisible storm. This constant 7 billion year-long bath of radiation would have had a profound and a transformative effect on the comet's surface. It is a process that is known as irradiation. The high-energy particles would have acted like a steady and a microscopic and a patient chemical hammer, breaking apart the simple and the volatile and the pristine ice molecules that made up the comet's original surface. The frozen water, the methane, the carbon dioxide, all of it would have been slowly and inexorably shattered. And then, in the deep and the patient cold, These broken atomic fragments would have slowly recombined, forming new and larger and much more complex and much more stable carbon-rich organic molecules. Over the course of the eons, this slow and patient process of cosmic ray chemistry would have built up a thick, a dark, and a tough outer crust, or mantle, on the surface of the comet. This dark, reddish, and organic-rich crust, the very substance that we now see in the color of the comet's dust, would have acted as a perfect and a beautiful and a natural shield. It is this ancient and this irradiated and this protective armor that has kept the comet's heart safe. Buried deep beneath this dark and tough exterior, the much more volatile and much more pristine ices of the comet's interior, the great reservoirs of carbon dioxide that have now so spectacularly come to life, have been perfectly and completely protected from the harshness of interstellar space. The survival of 3I/Atlas, the very fact that it has arrived in our solar system and is still alive, still capable of producing a beautiful and a glowing coma, is a quiet and a beautiful testament to its own incredible resilience. It teaches us that these interstellar objects are not just fragile and fleeting snowballs. They are, in a very real sense, natural and icy, and almost perfectly designed interstellar fortresses. This beautiful idea of a protective, irradiated crust may also give us a new and a more gentle way to understand the great mystery of our very first interstellar visitor, Oumuamua. Perhaps that strange and that dark and that asteroidal object was not so different from 3I Atlas after all. Perhaps Oumuamua was also a comet, its heart also filled with pristine and with volatile ices. But perhaps its own interstellar journey was even longer than that of our current visitor, or perhaps it had traveled through a much harsher and a more radiation-filled region of the galaxy, and perhaps over its own, even more ancient journey, its own protective, irradiated crust had grown so thick and so tough and so completely impenetrable that even the warmth of our own sun was not enough to awaken the ancient and the volatile and the beautiful ices that might still be sleeping. Silently and eternally, in its deep and its quiet and its well-protected heart. The final and a beautiful lesson from the long and the lonely journey of Atlas, then, is a lesson in the profound and the quiet power of endurance. It is a testament to the fact that even a small and a simple and a fragile object can, with the right kind of protection, survive a journey that is longer than the entire existence of our own planet. Our messenger is not just a message in a bottle. It is an incredibly and a beautifully and a naturally well-built bottle. The long and patient journey of our interstellar messenger has now taught us a series of profound and beautiful lessons. Its strange and ancient chemistry has revealed that the recipe for building worlds is not a universal one. Its incredible speed has told us a story of a violent and a chaotic home, and its very survival, after a journey of 7 billion years, is a quiet and a beautiful testament to its own incredible resilience. We have, so far, treated 3I Atlas as a singular and a unique object, but it is not entirely alone. Its arrival is the third act in a grand and unfolding scientific drama. With its confirmation, humanity has now officially welcomed 3 known visitors from the interstellar void. And with these 3 precious data points, we can begin, for the very first time, to move from the study of a single, strange anomaly to the study of a true galactic population. We can now place our messenger in context, comparing it to its predecessors, and in doing so, we can begin to read a much larger and more profound story, a story about the beautiful and the surprising diversity of worlds in our Milky Way galaxy. Let us first, in our quiet journey, cast our minds back to the year 2017, to the arrival of our first confirmed interstellar visitor, 1I Oumuamua. It was a profound and a baffling enigma from the very beginning. Unlike a traditional comet, it showed no visible signs of a glowing coma or a tail. It appeared to be an inert asteroidal object, dark and reddish in color. Its most famous characteristic was its extreme, elongated shape, a conclusion that was inferred from the wild and dramatic swings in its brightness as it tumbled through space. It was a cosmic cigar, or perhaps a thin, flat shard, a shape unlike any known object in our own solar system. And to deepen the mystery, it exhibited a gentle but undeniable non-gravitational acceleration, a tiny push away from the sun that could not be explained by gravity alone, and yet there were no visible jets of outgassing to account for it. Oumuamua was a profound and still unsolved puzzle. It was a messenger that arrived, speaking a language we did not recognize. It was the great cosmic question mark. Then, just 2 years later, in 2019, our second visitor arrived, 2I Borisov, and it was, in almost every way, the perfect and reassuring opposite of Oumuamua. From the moment it was discovered, Borisov looked and behaved almost exactly like a classic long-period comet from the most distant reaches of our own Oort cloud. It had a well-defined, glowing coma and a beautiful long tail of dust. As our telescopes studied its chemical composition, they found that it was made of a familiar recipe of water ice and other molecules, in proportions that were remarkably similar to our own native comets. Borisov was a deep and profound comfort. Its message seemed to be that despite the vast distances, the fundamental building blocks of planetary systems, the dirty snowballs that form in the outer reaches of other star systems, might not be so different from our own. It was a familiar stranger, a welcome sign that the chemistry of our own home might be a common blueprint throughout our galactic neighborhood. It was the great cosmic reassurance. And now, into this small but already fascinating family arrives our third messenger, 3I Atlas, and it is once again completely and utterly different from the two that came before it. Like Borisov, it is clearly an active comet with a glowing coma and the beginnings of a tail. But that is where the similarity ends. As we have learned, its chemical composition is deeply anomalous, a strange and exotic recipe that is dominated not by water, but by carbon dioxide, setting it apart from Borisov and from all the comets of our own solar system. And its kinematics, its motion through the galaxy, are in a class of their own. Its incredible speed and its ancient origin from the galactic thick disk make it a fundamentally different kind of object from both Oumuamua and Borisov, whose gentler speeds are consistent with an origin from our own local thin disk of stars. So what is the great unifying message that these three messengers have delivered to us? The most profound and important message is that diversity itself seems to be the rule. The most significant finding is their incredible diversity. If our first visitor had been like Borisov, we might have concluded that all other solar systems are just like ours. If our second visitor had been like Oumuamua, we might have concluded that the galaxy is filled with strange and inexplicable objects. But to have three visitors, and for all three to be so profoundly different from one another, a strange inert rock, a familiar water-rich comet, and an ancient carbon dioxide-rich comet, is the most exciting and most wonderful outcome of all. It is a powerful and direct piece of evidence that the process of building planets in our galaxy is not a uniform one. It suggests that the protoplanetary disks around other stars, with their unique chemistries, their unique temperatures, and their unique histories, are creating an immense and beautiful variety of building blocks. There is no such thing as a typical interstellar object. The galaxy is not a monoculture. It is a place of immense and wonderful variety, a great garden in which 1 billion different kinds of cosmic flowers are blooming. The arrival of our 3 distinct and beautiful interstellar messengers has now given us the first, faint, and tantalizing outlines of a new and a much grander cosmic story. The profound and the wonderful diversity that exists between the enigmatic Oumuamua, the familiar 2-eye Borisov, and the ancient 3-eye Atlas has taught us a deep and a humbling lesson. It has taught us that the great and the beautiful process of building solar systems is not a uniform one, that the galaxy is a place of immense and of wonderful variety. And this lesson, in turn, now leads us to the heart of the greatest and the most profound of all human questions. The question that is the quiet and the patient engine of all of our explorations. What does this new and beautiful and complex story mean for the possibility of life beyond the Earth? The first and the most hopeful of all the lessons is a simple and a beautiful one. The building blocks for planets and for life are everywhere. The very fact that these 3 distinct wanderers have traveled for perhaps millions or even billions of years through the harsh and the empty void, and have arrived in our solar system still intact and still carrying their precious cargo of rock and of ice and of complex, carbon-rich organic molecules, is a powerful and a direct confirmation that the raw materials of existence are common and are robust and are widespread throughout our entire galaxy. The universe, it seems, is a generous and a fertile place. But the story of 3-eye Atlas adds a new and a beautiful and a subtle layer to this understanding. It has taught us that the recipe for these building blocks is not always the same. Our own native comets, the messengers of our own solar system, delivered a chemical recipe that was rich in water, the great and the universal solvent that fills the oceans of our own living world. But the recipe that 3-eye Atlas has carried to us from its ancient and its long-vanished home is a different one. It is a recipe that is dominated by carbon dioxide, and this raises a beautiful and a fascinating question. We have always, in our search for life, been looking for worlds that are like our own, worlds where a water-based chemistry could thrive. But what if life on another world, in another and a more ancient star system, began with a different set of ingredients? The beautiful and the profound diversity of these cosmic messengers is a quiet and a gentle and a powerful reminder that we must be humble and that we must be open-minded in our search for life. It is a whisper from the cosmos that tells us that our own beautiful and water-rich story of life may not be the only story that the universe knows how to write. The second, and the more sober of all the lessons, is one of stability. The incredible speed of 3-eye Atlas has told us a quiet and a beautiful story of a violent and a chaotic home. Its journey began in a great and a powerful and a gravitational cataclysm. And this is a profound and a humbling reminder. While the ingredients for life may be common and widespread throughout the galaxy, the stable and peaceful environments that are needed for life to take hold and to survive and to evolve for billions of years may be incredibly and profoundly rare. The great and the beautiful story of life on our own Earth was made possible not just by the delivery of the right ingredients, but by the long and the patient and the almost unbroken peace of our own stable solar system. We have had a quiet and a well-behaved star. We have had the protection of a great and a giant and a guardian planet, Jupiter. And we have had the gentle and the stabilizing and the beautiful influence of our own large moon. The violent and the chaotic story that is written in the very motion of 3-eye Atlas is a quiet and a beautiful reminder that this kind of peace and stability may be the rarest of all cosmic treasures. And the final and the most profound of all the lessons is a lesson of time. The ancient and the 7-billion-year-old origin of 3I Atlas has opened up a vast and a new and a previously unimagined expanse of cosmic time in which the great and the quiet experiment of life could have begun. It tells us that the conditions for the formation of planets and the raw chemical materials for life have existed in our galaxy for billions of years longer than our own solar system has been around. This beautiful and this humbling realization places our own existence in a new and a more mature perspective. We are not the first children of the universe. We may, in fact, be the youngest, the most recent arrivals in a galaxy that has been filled with the deep and the quiet potential for life for an almost unimaginably long time. The beautiful and the profound story of our interstellar visitors, then, is a story that both expands our hope and deepens our humility. And it is a story that has only just, in our own brief and beautiful moment of cosmic time, truly begun. Our exploration of our interstellar visitor has now given us a profound and a beautiful new context for our own existence. The strange and the ancient story of 3I Atlas, with its different chemistry, its violent history, and its long, lonely journey, has taught us a series of deep and important lessons about the vast and the beautiful diversity of other alien solar systems. And now, in this quiet and reflective part of our journey, we must take the final and most important step in this exploration. We must turn the great cosmic mirror of our understanding back upon ourselves. For one of the most powerful and most beautiful things about looking out into the great, dark ocean of the universe is that it is often the best and the truest and the most honest way to truly see our own home for the very first time. The story of 3I Atlas, in its beautiful and its alien strangeness, gives us a new and a powerful background against which we can appreciate the series of quiet and of beautiful and of almost miraculous accidents that have made our own solar system and our own planet a safe and a nurturing harbor for life. The first of these great gifts is the nature of our own star. The parent star of 3I Atlas was, as we have learned, likely an ancient and a chemically primitive and a dynamically hot star from the galactic thick disk. And the most common stars in our galaxy are the small, the dim, and the often violent and unpredictable red dwarfs. Our own sun, by contrast, is a G-type yellow dwarf star, a star that is in the perfect and the relatively rare sweet spot. It is massive enough to be stable and long-lived, and it has shone with a gentle and a reliable and a predictable light for more than 4 billion years, giving the slow and the patient and the beautiful story of life on our planet more than enough time to unfold. The second gift is the gift of our own unique chemical recipe. The carbon dioxide-rich nature of 3I Atlas has taught us that the building blocks of worlds are not a universal standard. The fact that our own primordial solar system was born from a cloud of gas and dust that was particularly rich in water ice is one of the most important and the most fortunate facts of our existence. It was this water richness that allowed our planet to be born with the vast and the beautiful and the life-giving liquid water oceans that are the single most defining feature of our world. A planet can be in the perfect, habitable zone of its star, but if the comets that deliver its volatile materials are of a different and a drier and a more carbon dioxide-rich nature, like 3I Atlas, then the path to becoming a true and a stable and a water-rich, habitable world may be a much more difficult or even an impossible one. And the final, and perhaps the most precious gift of all, is the gift of peace. The violent and the high-speed and the chaotic ejection of 3I Atlas has told us a story of a solar system that was likely a turbulent and an unstable and a gravitationally violent place. Our own solar system by a beautiful and a profound stroke of good fortune, is the opposite. It is a place of a deep and a lasting and a beautiful architectural stability. The orbits of our planets are merely circular and are widely spaced, a configuration that has allowed our world to remain in a stable and a predictable path for billions of years. And our solar system is blessed with the presence of a great and a giant and a gravitational guardian. The planet Jupiter, in its distant and its stable orbit, has acted as a great cosmic shield for our world, its immense gravity deflecting and disrupting and ejecting many of the comets and the asteroids that might have otherwise been on a collision course with the Earth. The story of 3I Atlas, then, when we hold it up as a mirror, becomes a quiet and a beautiful illustration of a scientific idea known as the rare earth hypothesis. This is the idea that while simple microbial life may be common and widespread throughout the cosmos, the long and the specific and the incredibly unlikely list of ingredients and conditions that are required for a stable and a complex and a conscious biosphere like our own may be incredibly and profoundly rare. The story of our interstellar visitor has given us a beautiful and a physical and a direct piece of evidence that the universe is, indeed, a place of immense and of beautiful diversity. And in that diversity, we can now, with a new and a more profound and a more quiet sense of gratitude, appreciate the true and the beautiful and the almost impossible preciousness of our own quiet and stable and life-giving home. Our quiet and patient astro-archaeological investigation is now drawing to a close. We have taken our one precious and ancient artifact, the Comet 3I Atlas, and we have read the beautiful and the profound stories that are written in its substance and in its motion. Its strange chemistry has taught us a lesson in the beautiful diversity of cosmic recipes. Its incredible speed has told us a story of a violent and a chaotic home. Its very existence, after a journey of 7 billion years, has revealed to us a galaxy that is a vast and an interconnected ecosystem, constantly and patiently sharing the raw materials of creation between its stars. The lessons from our messenger have been deep, and they have been transformative. And yet, for all that we have learned, the true and the most honest conclusion of any great act of exploration is a humble one. It is the quiet and the gentle realization of how much we still do not know. The story of 3I Atlas, as rich and as beautiful as it is an incomplete one. An artifact, a single, lonely fragment from a lost world, can only ever tell us a small and a partial part of the story. And the arrival of our interstellar visitor has left us not just with new knowledge, but with a new and a beautiful and a profound set of unanswered questions, mysteries that will likely remain with us for a very, very long time. The first, and the most immediate, of these great quiet mysteries is the story of the comet's own long-vanished family. From its speed and its trajectory, we have been able to deduce that it was born in the ancient and the chaotic and the star-crowded neighborhood of the galactic thick disk. But this is a description of a vast population of billions of stars. Which one of these ancient and now likely long-dead stars was its true parent? This is a question we will almost certainly never be able to answer. The chaotic and the ever-shifting gravitational tides of the Milky Way galaxy over a period of 7 billion years have completely and utterly scrambled the comet's original path. We can know the general direction from which it came, but we can never trace its beautiful and its lonely journey all the way back to its specific and its long-forgotten front door. And because we cannot know its star, we cannot know the true and the detailed story of its home solar system. Our comet is a single and a beautiful and an informative piece of a colossal and a cosmic and a three-dimensional puzzle. a puzzle for which we have no other pieces. Its violent ejection tells us that its home was likely a place of great, and of chaotic, and of gravitational instability. But what was the true architecture of this ancient and alien world? Did it have great and gas giant planets like our own Jupiter? Did it have smaller and rocky and terrestrial worlds? And most tantalizingly of all, did it have an Earth-like planet orbiting in the gentle and the life-giving warmth of its habitable zone? These are the quiet and the beautiful questions that our single and our lonely and our icy messenger can never answer for us. It can bring us the recipe of its raw and its primordial and its planet-building materials, but it cannot tell us the story of the beautiful and the complex and the finished worlds that may have been built from them. And this leads us to the final and the most profound and the most deeply human of all the unanswered questions. The reddish and the organic rich and the beautiful dust of 3I Atlas has told us that the building blocks of life were present in its ancient and its chemically primitive home. The potential for life was there, but did that potential ever blossom into a reality? Did the great and the quiet and the beautiful miracle of life ever take hold in that distant and long-vanished world? This is a question that a single and a sterile and an icy messenger can never answer. It has brought us the recipe, but it cannot tell us if the meal was ever cooked. It has brought us the beautiful and the hopeful first chapter of a story whose final and most important pages will forever remain unread. The story of 3I/Atlas is a profound and a beautiful lesson in the very nature of archaeological evidence. An artifact can tell you a great deal, but it always and inevitably leaves you with a sense of a story that is incomplete, a sense of a world that is beautiful and that is rich and that is forever just beyond your reach. And these beautiful and these quiet and these unanswered questions are not a failure of our science. They are the very things that will drive the next great generation of our exploration. They are the quiet and the patient and the beautiful motivation that will inspire us to keep building our great and our powerful and our ever more sensitive telescopes. And they are the reason we will continue to watch the skies with a quiet and a patient and a hopeful sense of wonder, waiting for the next beautiful and mysterious messenger to arrive. A messenger who might just be carrying the next and the missing and the beautiful piece of the great and the cosmic and the wonderful puzzle. Our long and quiet astro-archaeological investigation is now complete. We have taken our one precious and ancient artifact, the comet 3I Atlas, and we have read the beautiful and the profound stories that are written in its substance and in its motion. Its strange chemistry has taught us a lesson in the beautiful diversity of cosmic recipes. Its incredible speed has told us a story of a violent and a chaotic home. Its very existence, after a journey of 7 billion years, has revealed to us a galaxy that is a vast and an interconnected ecosystem, constantly and patiently sharing the raw materials of creation between its stars. We have followed the evidence as far as it can take us, and we have been left with a set of beautiful and profound and enduring unanswered questions. And now, as our journey comes to its final, quiet close, it is time to ask, what is the single, great, and overarching lesson that this entire encounter has to teach us? The final and the most beautiful message of our interstellar visitor is that the universe is not just a collection of objects and of laws. The universe is a collection of stories. Every single star system, in its own unique corner of the galaxy, is a complete and a beautiful story of creation. It has its own unique characters, its planets. It has its own unique plot, its dramatic and its dynamic history, and it is written in its own unique chemical language. Our own solar system is one such story, a story of a quiet star, a stable architecture, and a beautiful, water-rich, and life-bearing Earth. It is the story that we know and love. It is the story that we are a part of. And the interstellar objects, the great and the silent wanderers, like 3I/Atlas, are like single, torn-out pages from these other and distant and beautiful books. They are pages that have been ripped from their bindings by the great and the chaotic and the violent forces of cosmic history, and they have drifted for eons across the great and the silent and the dark library of our galaxy to finally, and by a beautiful and a miraculous chance, land upon our own quiet reading desk. Each page that we find tells a different and an incomplete part of another and a greater story. The page that was Oumuamua was strange, and it was beautiful, and it was written in a language of physics that we could not, and still cannot, fully decipher. The page that was 2I Borisov was a comforting and a familiar one. It was written in a language that was remarkably similar to our own, and it told a story of a solar system that was, in its fundamental recipe, very much like our own home. And the page that is 3I Atlas is the most ancient and the most profound of all. It is a page from a much, much older volume in the great cosmic library. And it is written in an older and a more primitive and a beautiful chemical dialect, a language that tells us a story of what the universe was like in a long-vanished and a forgotten era. And in this beautiful and this humbling metaphor, we can find our own true and proper place in the cosmos. We are not the authors of this great and cosmic library. We are the readers. We are the quiet and the patient and the humble astro-archaeologists. And our great and our noble and our beautiful task is to try and piece together the grand and the universal and the beautiful narrative of existence from the few and the precious and the often fragmented pages that we are lucky enough to find. This is a perspective that is both deeply humbling and deeply empowering, and it gives our great and our human quest for knowledge a sense of a profound and of an almost sacred purpose. And so, the ultimate message of our interstellar visitor is one of profound and of beautiful and of quiet hope. It is a physical and a tangible confirmation that our own beautiful story is not the only one. The great, silent library of our galaxy is filled with a countless and an unseen and a beautiful multitude of other stories, each one unique and each one precious. To know this is to be forever and completely freed from our own cosmic loneliness. It is to be invited into a state of a perpetual and of a quiet and of a beautiful wonder. Our long and quiet journey is now at an end. We have followed the path of a messenger from a star system that is older than our own. We have become astro-archaeologists, and we have gently and patiently read the ancient chemical story that it has carried for so long. Its message is one of profound and of beautiful diversity, a quiet reminder that our own story is just one of a countless multitude in the great silent library of the cosmos. The story is now told. The great cosmic library will be there for us to explore another night. But for now, the only task that remains is to close the book on your own day and to find your rest in the quiet and the peaceful darkness. There are no more mysteries to solve, no more ancient worlds to find. There is only this moment, only this quiet, and the gentle and the easy and the natural invitation to drift off into a deep and a peaceful sleep. Rest now, just rest. The journey continues, always calmly, always at the pace of the universe.